Okay, parallel lines, and shortly we'll be talking about perpendicular lines. Two lines are parallel if they extend forever and never cross. Okay, they never touch. Now there's something else special about parallel lines. They do have to be in the same plane. It says in a coordinate plane. Two non-vertical lines are parallel. We'll get into that in a second. But it can't be two lines that are not in the same plane because we actually have a different type of line. Imagine this. Imagine you've got a line, and then you've got this other line up here. That doesn't look like a line, does it? You know why? Because it's coming straight at you. You're just seeing the tip of it. Okay, imagine those two lines. You've got this line that's running this way, and you've got this other line that's actually coming out of the screen straight at you. Do those two lines cross? One's running towards you, the other one's running left and right. Those two lines never cross. Excuse me. Are those lines parallel? No. Those are called, and we don't do a lot of this, but it's called skew lines. Skew lines are two lines that could be in different planes. This line is in the plane that the screen is on. This line is not in the plane that the screen is on. Okay, this line is coming at you. It's in a completely different plane. So just because two lines don't cross doesn't necessarily mean they're parallel. If they're in the same plane, yes. Okay, those two are in the same plane. They're both on the screen. Two lines are parallel if they never cross and they're in the same plane. Now, what's special about parallel lines, and that's what we're getting into here. Let's see what I've got here. Let me blow this up. Well, two lines are parallel if they have the same slant. Look at these two lines here. In order for those two lines to be parallel, notice that the rise and the run has to be the same. Okay, I can move this around to wherever I want to. But to make a long story short, parallel lines have the same slope. Okay, if one line has a slope of 2 over 1, 2, 3, 4, this is a slope of -1/2. The other line will have a slope of -1/2 if it's parallel. And while we're at it, let's go ahead and knock out perpendicular. Okay, perpendicular lines. Perpendicular lines are lines that cross at 90-degree angles. This is a 90-degree angle. This is 90-degree. It actually forms 4 90 degrees, right? If two lines are perpendicular, you have 4 90-degree angles. Now, their slopes. Let's scroll up here and see if it's, what's it tell us? Okay, here we go. My gray line here has a slope of -1/2. My red line has a slope of +2/1. Let's change this up some. Let's move some of these. Well, it's locking it in perpendicular. That's good. There we go. Here, my one of my lines has a slope of -3/4. My other line has a slope of +4/3. That's weird. It's a different type of relationship. With perpendicular lines, let's go ahead and move on to it, and then we'll go ahead and cover both at the same time. This is the way most of your books write it. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. I don't like that. I don't like wording it like that. In order to be perpendicular, slopes must be opposite reciprocals. Is how I like to write it. Examples. Again, lines that are parallel have the same slope. Lines that are perpendicular have opposite reciprocal slopes. Example, 2/3 and -3/2. The word opposite meaning one of them is positive, one of them is negative. Reciprocals, or multiplicative inverses, are flips of each other. So 2/3, -3/2. 4/5 and -5/4. Those would be perpendicular. All right, Chris, with me? Awesome. Another example. 7. What would be perpendicular with 7? -1/7. To flip 7, you need a 1 on bottom. Okay? Everybody understand that? So parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. First problem here says line N1, N subscript 1. Remember we talked about subscripts. This, the first line, and then you got N2 saying the second line. Line N1 has the equation y equals negative 1/3 x minus 1, and we can see that. It has a y-intercept of negative 1, has a slope, rise negative 1, round 3, yeah, that's right. Line N2 is parallel to it and passes through the point 3, 2. Write an equation for N2. This will be pretty easy. In order for it to be parallel with y equals negative 1/3 x minus 1, Brianna, from what I just said, what must be true about their slopes? To be parallel. Same slope. In order to be parallel, because look guys, slanted the same, right? Is one steeper than the other? No. What is slope? It's the measure of steepness. So since one is not steeper than the other, they must have the same slope. And I'm glad they graphed this for us, aren't you? Because instead of going through all that trouble of what we normally have to do, we just look. Line N1 has a slope of negative 1/3 and passes through the point negative 1. That's what it says right here. Line N2 that we're looking for the equation of, we want it to pass through the point 3, 2. Well, Jordan D, can you, I don't know if you can sit back there. Could you help me out and tell me how I finish this up? Y equals negative 1/3 x. What? Okay, let's make it for up. Plus 3. And again, it was easier because it was already graphed for us. So what did we have to do? Look right there and see where it crossed the y-axis. They're parallel because they have the same slopes. And on top of that, they can't have the same y-intercept in order to be parallel. Then it'd be the same line. But where does it cross? Positive 3. Now let me work this problem minus the graph. And this is what you'll be doing. I'm looking for the line that is parallel to y equals negative 1/3 x minus 1. In order to be parallel to that line, we know that that must be true. They have to have identical slopes. But the problem is, I don't know what the y-intercept is. Well, this line that I'm looking for, we want to pass through the point 3, 2. So what do? I plug in 3 for x, and I plug in a 2 for y, and I make it true. There's absolutely zero difference between this problem and the problems you worked yesterday. Okay, as long as you know parallel lines have the same slope, then you're looking for the line that has a slope of negative 1/3 that passes through the point 3, 2. That's what you did yesterday, same thing. Well, how do I find that? Like this. Plug in 2 for y. Plug in 3 for x. When you multiply negative 1, we can do it down here. Negative 1/3 times 3, you get 3 over 3 or negative 1. Now we got to make that a true statement. 2 is equal to negative 1 plus something. Well, I can't think of what that something is. Let me show you how else you can do that. You just move the 1 over there. Now, can you think about it? Take minus 1, move it to the left side. How do you move minus 1 to the left side? Plus 1. What do you get? 3. So therefore, how can I make this a true statement? I tack on plus 3. That's the exact same thing we got a while ago. And if we look, again, we can see that it does cross a positive 3. Let's try another. Write the equation of a line that passes through point P that is parallel to y equals negative x minus 5. Like I said, there is absolutely zero difference between this problem and the problems you worked yesterday. I want my line to be parallel to this, which, by the way, here's an abbreviation. Parallel, abbreviation, looks like 2 L's. I want it to be parallel to that line, y equals negative x minus 5. Remind me, Cole, if 2 lines are parallel, what must be true? Same slope. What's the slope of that line, Cole? there, right? -1. In order to be parallel to that line, it needs to have a slope of -1. Well, we want it to have a slope of -1, and we want it to pass through the point -3, 6. Let's try that again. For those of you that worked your homework last night, was that what your homework problems look like? Yeah, it's the same thing. Okay, what's the only difference? They didn't tell you what your slope was. You had to find it. Another mistake somebody in here is going to make today. Even though I tell you what I'm about to tell you, somebody will make the mistake that I'm fixing to say. Does anybody know where we're going to use that -5 right there? Absolutely nowhere. It's pointless. Okay? Do not do anything with that -5. Why did they give you that equation? They simply said, I want my line, the line you're looking for, to be parallel to that. Well, could they said, I want the line to be parallel to -x minus 7? Or I want my line to be parallel to y equals -x plus 1, or y equals -x plus 3? Yeah, any of those would work. We want our line to be parallel to any of these. So what does that tell us? Simply this. We want our slope to be -1. The rest of it is pointless information. Oops, ignore that. So now let's work it. We're looking for the equation of the line that has a slope of -1 that passes through the point -3, positive 6. Y equals -1x blank. Shortcut. This is my shortcut. Plug in y, plug in x. When you do that, you get, here's my y, xy, right? 6 is equal to -1 times -3, which is a positive 3. That is not a true statement. Make it a true statement. Plus what? Good. And again, for those of you that can't figure out what question mark is, you can't figure out what goes in the blank. I don't know if you've noticed that right there. Again, that's a linear equation. How do I solve that? I take 3 and I move it over here. How do I move 3 over? You do -3, 6 minus 3, which is 3. Okay. So therefore, and I'm not a big fan of -1x. If you'd rather write that as y equals -x plus 3, that is fine as well. Let's check. I actually graphed it beforehand so you can see this. I was looking for, it says find a line parallel to -x minus 3 or minus 5 that passes through -3, 6. -3, 6. And I want it to be parallel to this. And I found out that y equals -x plus 3 fits that. Is that true? Yeah. Y equals -x plus 3, which is right here, is parallel because they have the same slopes, and it passes through the point 3 or -3, 6. It does check out. Now let's work a perpendicular one. Before we find an equation, let's do this. Let's determine, are these lines perpendicular? A lot of people says, yeah, looks like a right angle, it's good, it's perpendicular. No. Can't do it anymore. Looks can be deceiving. In geometry, if I ask you why something is true, let's learn something right now. Why is that true? Never say because it looks like it is. Never. Never. Why? That's a 90-degree angle, right? Well, what if it's 91 degrees? We don't know. If it's 91 degrees, it's not perpendicular. That must be a 90-degree angle or it is not perpendicular. We have to have some way to prove. And if we're looking for perpendicularity, we want to know that are these two lines perpendicular? Always resort to slope. Okay? Well, can't we just take the protractor and measure it? Here, let's see. We take, I got my math tools here. Couldn't we just take, and we learned how to do this first chapter. We just take our protractor, and we just line it up right here, and we flip it around, we measure. Why can't we do that? Well, I don't don't know if you can tell, but it looks like it's close to 90 degrees, but I don't know what if it's 89.9? Right? What if it's slightly off from 90 degrees? Gotta have another method. And here's what we're gonna do. We're gonna find slope. Nicole, help me. 0, 3, and 3, 1 are 2 points on the red line. 0, 3, and 3, 1. Nicole's slope is y2 minus y1 over x2 minus x1. Help me find the slope there. What's y2 minus y1, Nicole? Good. So I have -2 over what's x2 minus x1. Good. So the slope of my red line is -2/3. JC, help me with the white line. There's the blue line. 2 points that are on the blue line are 0, 3, and -4, -3. 0, 3, -4, -3. JC, what is y2 minus y1 there? There you go. And that's tempting, right, guys? Anytime you have that -3 and you got to subtract 3 from it, that's so tempting to say 0. But make sure you remember -3 and -3, that's dead and dead, and she's exactly right, that is -6. And JC, what's x2 minus x1? We reduce that, negative divided by negative is a positive, 6 over 4 reduces to 3 over 2. Look at those two slopes. You have a slope of -2 over 3, positive 3 over 2. Those two slopes are opposite reciprocal, so therefore we can say those two lines are definitely perpendicular. Just for kids, let's go a step further, Chris. One more step. And I want to, let's find the equation of those lines, Chris. Hey, wake up. There you go. Write something down. Don't you stay away. The red line. What was my slope? -2/3. Somebody give me the equation of that red line. I'll do it in a minute. Y equals -2/3 x. Anybody? Plus 3. Good. We should be pretty quick at that. Okay. Finding the equation line, we only need 2 things. And we have a graph, and it's pretty easy to find those 2 things. We need a slope. Well, we found that. We need a slope and a y-intercept. Right there's my y-intercept at +3. What about the blue line? Y equals 3/2 x. Somebody finish it for me. Plus 3, same thing. And by looking at the equations, everybody understand why those 2 lines are perpendicular. You can see it very easy. Opposite reciprocal slopes. Okay. That's enough of that. Here's the ones I'm interested in. Write an equation in slope-intercept form for a line that is perpendicular to y equals, we need it to be perpendicular. There's your symbol. Upside down T. Why is that the symbol? Well, they're perpendicular to each other. We want it to be perpendicular to y equals -3x plus 2. Let's simplify that. In other words, if we want it to be perpendicular to y equals -3x plus 2, Megan, what's the slope of y equals -3x plus 2? Good. In order for it to be perpendicular, Megan, what do we need our slope to be? Instead of -3, we need it to be positive, what? Opposite? There you go. The slope of this line is -3. In order for our line to be perpendicular to that, it needs a slope of positive 1/3. Opposite reciprocals. So, in other words, we're looking for a line that has a slope of 1/3 and that passes through the point 4, 0. That makes sense. Just like last section. Y equals mx plus something. In order to find the something, we plug in 4, 0. Let's do it in a different color here. 0 equals 1/3 times 4, I believe it would be 4/3. Finish the statement. 4 4/3, what can we take 4/3 minus what, Vanessa? What can we subtract from 4/3 to give us 0? 4/3, good. 4/3 minus 4/3 is 0. So therefore, what completes my statement would be a minus, I can't write it, 4/3. That's a 3. So my equation is y equals 1/3 x minus 4/3. That is the line that is perpendicular to this, that passes through the point 4, 0. Another way of saying that, I believe that's an x-intercept. It has an x-intercept of 4. Okay. Carson, look for a line that passes through -2, 2. That's a point on my line that has a slope perpendicular to y equals -5x minus 8. Carson, what is the slope of -5x minus 8? Good. So in order to be perpendicular to that, my line needs a slope of what? 1/5. The slope of this line is -5/1. My line needs a slope of positive 1/5. Then you work it just like you worked yesterday. I'm going to work this one, point slope formula and shortcut. Just in case some of you don't understand shortcut, here's your point slope formula. Y minus y1 equals m times x minus x1. I believe you have it written on your formula sheet. You can use it on your test. Y minus, this is x and y, x1, y1 if you want to put that. Y minus 2 equals m times x minus -2, makes it a plus. Distributive property, y minus 2 equals 1/5 x plus 2/5. Uh-oh, that fraction. This will be tough. Minus 2, we got to move over here and put with 2/5. How in the world do we add 2 holes with 2/5 of a hole? Anybody know what to do? You have 2 whole pies and you have another 2/5 of a pie. I believe you would have 2 and 2/5. 2 holes and 2/5 would be 2 and 2/5. Makes sense. That's point slope method. If you like that method, go for it. I'll go ahead and tell you shortcuts a little bit tougher normally when you have fractions. I know my equation is y equals 1/5 x plus something. But the problem is finding out what the, well, we know what it is right here. But the problem is finding out what the y-intercept is, finding out what is the plus something. The way that we find it out, we plug in the points. Y equals m times x. 1/5 times -2 would be -2/5. And then we got plus whatever. I'll put plus question mark. Well, how do we figure out what the question mark is? You got to figure out what in the world you're going to add to -2/5 and give you 2. That's hard, okay? Unless you just take this and move it around. To find out what you add to -2/5 and give you 2, we'll just take that -2/5 and solve that basic equation. -2/5, if I want to move it over here with the 2, becomes plus 2/5. 2 plus 2/5 is that same 2 and 2/5. And I'll